So in this lecture, we are going to discuss few more questions on the of the rotation about fixed axis. For example, in the Newton's laws of motion, right? You have seen if this is the small m and this is the capital M. In that case, we assume that pulley is ideal. Ideal pulley. What is the meaning of the ideal pulley? The ideal pulley and the string is massless. So ideal pulley mean the pulley is frictionless and massless, right? So in that case, what we have done, this is the mg, right? This is the capital mg, right? If it is mg a, so what is the net force is equal to ma? The net force is the mg, capital mg minus small mg, and the total mass m into a. So in that case, the acceleration we have found simple m plus m into g. So this was the acceleration, right? We have found in that case. Did you remember or not? You tell. Right now, but in this case, what we have given, suppose in this case the pulley is not ideal, the pulley itself has a mass, right? And if it is a mass, then it will have some moment of inertia, right? And the string is passing through this is the ideal or inextensible. This is m and this is the capital M, right? Now its moment of inertia is I. So what will happen, right? If capital M assumed to be big, so it will move with acceleration a, move up with acceleration small a. All right. So now you have to tell what is the acceleration and the tension that's of the string. So what will happen when this pulley will in this case, listen on this. In this case, when you solve, you assume that this is the string, the one tension. The tension in that case was in both cases was same, right? Here the mg minus t is equal to ma you applied. Here mg minus t minus mg you will apply ma, and when you will simplify the mg minus small mg, m plus m into a you are getting, and this is the acceleration. But in this case, if this is the rotating pulley, here the string slip over the pulley, but here the pulley is rotating, right, like this. Therefore the tension T1 and T2 in the string will be the different. Is it clear or not? In what is the difference between this case and this case? In this case, the pulley was ideal and the string slips. Ideal and string slips over pulley. But in this case, the string is rotating. In this case, the string is rotating with pulley. Are you getting this thing or not? So it is rotating like this. So therefore the tension T1 and T2 will be the different, right? So there will be two types of the motion included in the system: the translation motion of capital N and small m, and the rotation motion of this pulley, right? Here the tension T1 and T2 will be acting for this pulley, right? Leave this first. You tell me what is the Newton's second law for this capital M. The F net is equal to m into a. What is the net force for capital M? The mg minus T1 is equal to capital M into a. Equation number 1. For this block, this is T2 minus small mg, small ma, equation number 2. This is the translation motion of the two blocks. And if you consider the pulley, right, this is the pulley, suppose, and the mass of the pulley will be, suppose, the m dash g, and there will be the tension in this string, suppose the tension is T. So here the tension is T1, here is the tension is T2, and it is rotating like this. Are you getting or not? Can you write the net torque about O? Torque about O, you have to write, right? Listen one thing. If this point have the acceleration a, right? It's if there is a torque, so there will be some angular acceleration alpha of this pulley. So the angular acceleration of alpha of the pulley is alpha, right? So you have to find the torque about a, put it equal to I alpha, right? No. That is okay. Torque is equal to I alpha. You are telling if this is the point, the acceleration of this point is A, or the acceleration of this point is A, and the A is equal to R alpha, alpha is equal to A upon R, right? This is the thing. So alpha is equal to A upon R, that is true. But what is the torque in terms of T1, T2, M1G and T? Can you find the torque? Leave this alpha, leave this R. The only perpendicular distances are. Can you write the torque about O of the T1 and T2? Yes, we can write. Yes, listen one thing. About O, the torque of this tension and the weight about O is 0, no doubt. So now you tell. This is the two things, right? You may make, this is the tension T1, this is the tension T2. First of all, you tell me, is there any confusion between in the direction of the tension T1 and T2? It is always away from the body. Tension is always away from the body. For this, the tension is this, tension is this, in this direction. So can you tell me, if, listen one thing, if this is the alpha, right? So if this is the angular acceleration alpha, you take this direction positive. So out direction will be positive, or you can say in which direction the angular acceleration is, you have to choose that direction positive, right? So tell me, what is the torque, net torque, if you want to write, what is the torque of T1? This is the force multiplied by perpendicular distance. And what is the direction of the torque? The T1 torque is along the angular acceleration alpha, T1 into R, therefore it is taken with positive sign, while the torque of T2, right, torque of T2 is opposite to the direction of the alpha. So that is why minus T2 into R you have to take. And net torque, put it equal to I into alpha. Net torque is equal to I into alpha. Is it clear or not, you tell? So T1 minus T2 into R is equal to I into alpha. And what is the alpha? And A relation, alpha is equal to A by R, right? So T1 minus T2 is equal to IA upon R square, equation number 3. This is 1, 2 and 3. Add 1, 2 and 3. You can choose out direction is taken as the positive and the into direction is negative, right? So add 1 plus 2 plus 3 if you add. So capital Mg minus T1 is equal to Ma, right? T2 minus small mg is equal to small m, and T1 minus T2 is equal to what? Ia upon R square. The moment of inertia value in terms of the mass of the pulley and radius is not given. So that's why only the I you will write. 1, 2, 3. When you will add them, T1, T2 will cancel out. So mg minus small mg, and A is taken as a common. So here capital M, small m plus I upon R square. So therefore A will be equal to M minus M upon capital M plus small m plus I upon R square. So this is the acceleration of the system. After getting the acceleration of the system, from this equation and this equation, T1 and T2 can be found from equation number 1 and 2. Is it clear? Copy this. Okay, so in this question, listen one thing. You can consider, for example, there is a pulley, and this pulley is not an ideal pulley, right? A string goes over here, right? This is the capital M, and this block is small m, right? Like this. It is the small m, capital M, and the moment of inertia The moment of inertia of this pulley is I. This is the moment of inertia, and the radius is R. The radius is R. So then what you have to find? We have to find acceleration of capital M. So it will, there is a constraint. The acceleration of this capital M will be A in this side, A in this side. Again, this is not ideal pulley. The radius is R. So therefore, the tension in the both side will not be same. As we assumed in case of ideal pulley in Newton's laws of motion without rotation. So here T1 and T2 you can assume. The pulley is, the string is rotating with the pulley, right? String is rotating with the pulley. What does it mean? The pulley is also rotating. If it will come this side, so pulley will rotate in this side. So what is the direction of the angular acceleration alpha? Can you tell? What is the alpha? Say into the board, right? So here one equation you have to make for this, right? The another equation you have to make for this, right? This is the T2, and the one equation you have to write for this. Are you getting? This is performing the pure rotation motion. Pure rotation mean rotation about fixed axis, and these are performing the translation motion. Can you write the three equation? Please copy this. So for this, F net is equal to ma I will apply, right? The F net, what should I write? Tell. Very good. Is equal to capital Ma. For this, very nice. This is the translation motion. Now the torque is equal to I alpha. I will put torque is equal to I alpha. Yes, listen, the very important thing which make confusion for the student. If the rotating in this direction, right, in this direction, so into this direction you have to take with positive sign, right? If you am making here this is the pulley, right? Although there will be the M dash G of the pulley and there will be some hinge force, right? Hinge force by this support. I can assume this is the N1 and N2, right? I don't know the exactly hinge force, and the T1 and T2 are acting like this. You tell me, do you is this direction of the T1 and T2 is correct or not? You tell me, Varshaz. Right. So if this is the O and it is rotating like this, right? So what is the torque of the T1? What is the torque of the T1? This is the force into perpendicular distance. What is the net torque is equal to I alpha if you apply? For the T1, please tell. Plus T1R or minus T1R? Plus. Why it is T plus? Because its torque is along the direction of the alpha, right? So T1 into R. And what is the torque of this? The torque minus T2. It is the pulling torque, it is the preventing torque, right? It is the rotating torque, it is opposing torque. Minus T2 into R is equal to I into alpha. But we have this is the A. Listen, if this is the acceleration A and this is R, so what is the relation between A is equal to R alpha, right? So alpha is equal to A by R. So T1 minus T2 is equal to I A upon R square. Equation number 3. Are you getting or not? So when you will add equation number 1, 2, 3, you will get the acceleration 1 plus 2 plus 3. So when you will add 1 plus 2 plus 3, T1 will cancel out, T2 will cancel out. So what will be the force only? That capital Mg is equal to Ma plus small ma plus I upon R square into A. So the acceleration may be written as capital Mg upon M plus small m plus I upon R square, right? In one thing. So this is a simple question. This is the 1 meter, this is the pulley, right? This is the pulley over pulley, right? This is the one pulley and this is the another one pulley like this, right? This is the one pulley like this, and there's a string. This is the B block and this is the A block, right? Listen one thing. So the acceleration of the block B, so the acceleration of block A is downward direction, right? What is the acceleration? Say 5 meter per second square. So when its acceleration is this, the pulley is rotating like this. Are you getting or not? This string is wrapped over this system, all right, like this, and this string is wrapped over this small pulley. This is the pulley over pulley, right? So if this is the acceleration A, so it means the pulley is rotating like this. So the B is moving with the acceleration B in this direction. Is it clear or not? You tell. Right. So you tell me, what is the acceleration of if AB you have to find? Listen, if the angular acceleration is this is the, suppose this is the R1 is what, 1 meter. So if this is the angular acceleration, if this is the angular acceleration alpha, so what is the acceleration AB, this point? It is the AB. Every point have the acceleration AB. Every point has acceleration the AB. So what is the AB? If this is the small r, say AB is equal to what? Say R alpha. Is it clear? And R1, sorry, this is the R1. And what about this? What about this point from here to here? If it is rotating like this point is what? AA. This point is what? AA. So what is the relation between AA? This is the R2, suppose. So this AA must be equal to what? R2 into alpha. So although the angular acceleration of each point of the body is same, but because of different radius, the tangential acceleration will be different. So from here the alpha is equal to what? AB upon R1. From here the alpha is equal to what? AA upon R2. So the angular acceleration alpha are same. AA upon R2 is equal to what? AB upon R1. Is it clear or not? You tell. So AA is what? What is the acceleration? It is downward 5 into 2. R2 is what? Say 2 meter. And AB we have to find, this is the 1 meter. So AB is equal to 2.5 meter per second square. And this is in the upward direction. Is it clear or not? Copy this. For similar type of the question from my side, I am giving. Suppose this is the pulley, a small pulley, and it is kept on the big pulley. Suppose the radius is of this system is R, the 3R it is, right? It is hanging from a string like this, and one block is of mass, right? This is the 30 kg, and the another block is hanging from this is the 10 kg. Is it clear or not? This is the pulley, and the moment of inertia of the pulley is given as I, right? This is the moment of inertia. This is the radius R and 3R, all right, like this. So you have to find the radius. You may write it is the 1 meter, and this is radius is the 3 meter. The moment of inertia is 20 kilogram per meter square. Suppose its value is given, right? Then what will happen if the system is released from rest? What will happen? It will come down, it will move up, and this system will rotate, right? The pulley is not ideal, and the string does not slip over the pulley. So double pulley system, it is called the double pulley system. So you have to find the tension in this string, tension, find T1, T2, and the angular acceleration alpha of the pulley. Do you understand or not? Copy. Same as we have done in case of in Newton's laws of motion. If assume this is the acceleration A1, this is the 30g, this is the 10g and T2. When it will move like this, so it will come down, and the acceleration. In this case, the A1 and A2 will not be same as you have seen. Are you getting? First, we will find the relation between or the constraint between A1 and A2. right? Can you find the constraint between A1 and A2? Please tell me. First, we will find the relation between A1 and A2. How would we find? Suppose this is the 3 meter, this is the acceleration A1. So what is the A1? A1 is equal to R into alpha. And if you consider this the A2, right? So A2 is equal to what? Say R into alpha. So A2 is equal to alpha and A1 is equal to 3 alpha. So put alpha is equal to A2. So A1 is equal to 3A2. This is the constraint between the relation A1 and A2, right? So if A2 I assume A, so what should be the acceleration? It should be 3A. Now can I write the equation? Yes. For this 30G, I am writing the solution now, right? F net is equal to ma. I will apply according to Newton's second law. The 30G minus T1 must be equal to 30 into A. This is T2. Listen one thing, the A. What is the acceleration? So you will write 3A. And this T2 minus 10G must be equal to M into A. So this is the 90. Equation number 1, equation number 2. How many unknowns are there? T1, T2 and the acceleration A. We have the three unknown. So the 3 equation must be known, right? So the other equation will be found with the help of the torque, right? If this is the pulley, right, the mass of the pulley will be m dash, I am assuming, and the tension in this string is, suppose the T dash, I am assuming, right? This is the tension T1 over here, right? This is the tension T2 over here. About O, the angular acceleration is alpha. So if it is rotating like this, so which torque is positive? The outward direction taken with the positive, and therefore into direction will be taken as the negative. Can you write the equation torque is equal to I alpha? Copy this and write. So yes, the T1, suppose this is the 3 meter, right, and this is the 1 meter. So the torque of T1, this was the first step we have learned. Torque of the T1 is what? Out of the board. So T1 into 3 minus the torque, if this torque is into the board, opposite T2 into 1 is equal to what is I? I is 20 into alpha. Is it clear or not? So 3T1 minus T2 is equal to 20 alpha. All right. Right. And what is the relation between alpha and A? Alpha is equal to what? Say A2, and A2 I assume to be A. You understand this thing? So alpha can be written as 20 into A. This is the third equation only. Here the A is equal to alpha, right? A2 is equal to alpha. So then if you add the 1, 2, 3, then you will get the correct answer. Add 1 plus 2 plus 3, right? So this is the 3 and the 1 is what? This is 300 minus T1 is equal to 90A. Equation number 1 it was. This is T2 minus 100 is equal to 10A. Equation number 2. Now what you have to do? This is the 3T1. So it is better to multiply by 3. So this is 900 minus 3T is equal to 27A. Equation number 1, you may write like this. This is the T2 as it is. T2 minus 100 is equal to 10A. Equation number 2. Right? You are getting the thing what I am doing. Now add 1, 2, 3. T2 will cancel out with this. 3T1 will cancel out this. Are you getting? So 900 minus 100 is equal to what? Add them. This is 370A, right? 370A. So this is 800 is equal to 370A, and the acceleration is 80 upon 37 meter per second square. This is the acceleration. Once you find the acceleration, you can find the T1 and T2 from this is the equation number 2, right? T2 minus 100 is equal to 10 into A. T2 is equal to 100 plus 10 into 80 upon 37, right? When you will simplify, you will get the correct answer. And the T1, right? T1 from here, you can get the T1 from here, 300G, minus T1 is equal to 90 into A. This is the equation number 1. So T1 is 300 minus 90 into A. 300 minus 90 into A. 80 upon 37. So then you can simplify this further and then you can get the answer. Is it clear or not? Any doubt here you want to ask, Varsha? Right. So you are getting the concept rotation about fixed axis. For example, suppose this is the incline, right? This is the 37 degree. Suppose no friction is there and this is the 50 kg. Suppose this is the 60 kg, and now it is bounded over it. It is the pulley like this, and the string is wrapped over this. Are you getting or not? And it is connected to this. This pulley can rotate about this fixed axis. Is it clear? And the radius of this pulley is suppose the 0.5 meter, and this is the disc. This pulley is like a disc. Are you getting or not? This is the disc, and the mass M is, you can assume to be the 10 kg, and the radius is assumed to be the 0.5 meter. Is it clear or not? Pulley like disc. The pulley assumed to be always to be disc, right? In most of the cases, until unless it is not mentioned that it is ring. So what will happen? You tell. When it is released from rest, what will happen? It will fall down and it will rotate. It will translate motion. It will perform the rotation motion. Are you getting or not? So what you have to find? You have to find the A. You have to find the alpha. You have to find the tension. If block is released from rest, find from rest as shown in figure, right? Find acceleration A, angular acceleration, and the tension in the string. I think the question is clear. How can we solve this equation? Do you want some time to solve this?
Sir, actually I solved.
Okay, very good. So, okay, now let's see. This is the 60G sine 37, and this is the T. It is moving like this. So F net is equal to MA. I will apply, right? So what is then F net? 60G. This is 600 into sine 37, 3 by 5. So 12 पंजे 60. 360 Newton. This is the pulling force minus T is equal to 60 into A. I think you are getting this. This is the one equation. For this equation, you tell me torque is equal to I alpha. You have to apply. What is the torque? Listen, although there is a mass like this is the mass mg, and some hinge force will be there. Whatever the direction it is, I don't know. But the hinge force and the mg torque will be 0. Only which force will provide the torque? Say this is the T and this is the perpendicular, and this is the angular acceleration alpha. So this T torque is in the same direction. That is why the angular acceleration is alpha produced. So what is the torque? You will write T multiplied by perpendicular distance. The moment of inertia half mr square you have to find. Half m 0.5 r square, 5 5 25, right? And how much it is? 5 25, 25 125 kg meter square. So the moment of inertia is 1.25. Are you getting or not? You have to find the moment of inertia if it is not given in the question. And what is the relation between A and alpha? Say A is equal to R alpha. So alpha I will choose A upon R. And what is the radius? The radius is say 0.5, right? So this is the 2A. Alpha is equal to 2A. So here the 2 into A. This is 2.5A. T into R. You will write. And also what is the radius? The radius is 0.5, right? I'm writing here. The radius is 0.5. T into R is equal to 0.5. right? So T is equal to what? Say 5a, equation number 2. Right, now you can simplify. Copy this. Okay, now you can simplify. This is 360. If you put the value of T, it is 5a is equal to 60a. This is 360 into 65a. The acceleration is 360 upon 65. 13 पंजे 65, 5 सत्ते 35. Right, acceleration is 72 upon 13 meter per second square. This is the acceleration. So what is the alpha? Alpha is equal to 2 into a. 2 into 72 upon 13. This is 144 upon 13 radian per second square. This is the alpha. And how to find the tension? Tension is equal to 5a. Any equation you can choose. I am choosing this 5a. 5 into acceleration 72 upon 13. 5 दूनी 10, 5 सत्ते 35 और 36 upon 13 Newton. So in this way you can find the tension. Right? Copy this. Okay. So in this question, if once you find the acceleration, right, so can you find the velocity? Suppose this is the block, it is released from rest, right? After some time it will acquire some velocity. After some time it will travel some distance. So then again, suppose in the above question, find the distance covered, find distance covered in 2 seconds, suppose. So if it is released from rest, u is equal to 0. Also find velocity, right, after 2 seconds, after 2 seconds. I think you are getting the question now. Very simple. Then once you found the acceleration, so it becomes simple. The equation of question based on the equation of motion, the acceleration we have found 72 upon 13. So s is equal to ut plus half at square I will apply. So u is what? 0. The distance travel is 0 plus half a. This is the a into t square is the 2 square. Right? I think you are getting everything. So 2 will cancel out and 144 upon 13 meter will be the correct answer. And how to find the velocity after 2 seconds? V is equal to u plus at. That's the thing. Initial velocity is 0, acceleration is 70 upon 13 into 2. So velocity is 144 upon 13 meter per second. Is it clear or not, you? So this questions can be solved by equation of motion after that. The only extra thing, what is the only extra thing is over there? The translation motion we apply, we have to find the moment of inertia. We have to apply the torque is equal to I alpha. Right. Also we are using the relation A is equal to R alpha. Then all the thing is same as it is we have done in NLM. Right. So let's see another question. Suppose this is the rod, right? And this rod is hinged over this point, right? Like this, right? And this is connected to the string through a pulley, right? And this is the mass M over there, right? Like this. So it is initially at this position. This is the rod of mass M, length L. Are you getting or not? Connected to a massless string. The pulley is the pulley. This pulley is also the ideal pulley given in the question. Ideal pulley. And this string is also the ideal string. Ideal string means tension in both sides the string is what? Same. So if this is the block mass is M, then if it is released from rest, then what will happen? You tell. If it is released from rest, it will come down with some acceleration A. What will happen to this? You tell. It will perform the translation motion. And what will it perform? It will perform about this axis. Tell me the rotation motion. So and the angular acceleration will be, angular acceleration of this rod will be say alpha in this direction, because the tension will provide the torque in this way and it will rotate like this. It will come down. Are you getting or not? So what you have to find in this question? The acceleration of the block you have to find. Is it clear or not? One block is performing translation, one block is performing rotation motion. The angular acceleration alpha, translation acceleration, linear acceleration is A. There must be some relation between A and L, A and alpha. Can you write those equations by yourself? Copy this, I will give you one. So let's see. For this block, mg minus t is equal to ma. You will write. Yes, which Varshaz, listen. If you consider this rod, how many force will act upon this? This is the T, this is the mg, this is the n2, and this is the n1. Are you getting or not? So it is performing the rotational motion about O. Can you write down the torque? Torque for rod. Torque about O. Can you write the net torque? The N1 and N2 torque is 0, right? This is the mg. So Varsha, you tell which direction you have to take positive. The angular, it is rotated like this, so angular acceleration is alpha. So out direction you will take positive. So you tell me what is the torque of mg? Mg into say L by 2. Is it clear or not? So its torque will be in this direction opposite to alpha. So it should be taken with positive sign or negative sign? Negative. And how much it is? Force multiplied by perpendicular distance. Is it clear or not? You tell. And what about the torque of this T? The torque of T is same as that of the direction of alpha. So plus T into L. Is it clear or not? You tell. And that torque is equal to say I alpha. What is the moment of inertia about this end? Say ml square by 3. Is it clear or not? And this is the alpha. And what is the torque? You tell. The torque is T into L minus mg into L by 2. Is it clear or not? Varsha, you tell. If this is the acceleration A, what is the acceleration of this point? What is the acceleration of this point? The acceleration of this point will also be equal to A. So if this is the rod and the angular acceleration is alpha and this point has the acceleration A, although the different point acceleration will be different, but we know this acceleration which is same as that of block. So A is equal to R alpha, and what is the R over here? Say L. So the relation between A and alpha is A is equal to L alpha. So here in terms of in the place of alpha, I will put A upon L. Is it clear or not? If you take L common, T minus mg by 2, this is mla by 3, 1 L will cancel out, T minus mg by 2 is equal to ma by 3. Equation number 2. This is the equation number 1. Are you getting each and everything? Copy this. Okay, so add the equation 1 plus 2. So mg minus t is equal to ma, and the t minus mg by 2 is equal to ma by 3. When you will add, the mg minus tt will cancel out, right? Tt will cancel out, mg minus mg by 2, and when you will add 4 ma by 3, right? So this is mg by 2 is equal to 4 ma by 3. So acceleration will be equal to 3g by 8. Is it clear or not? This is the acceleration, and therefore the tension we can find from here. The tension is equal to mg by 2 plus ma by 3. So mg by 2 plus m by 3 into 3g by 8, right? So the tension will be equal to mg by 2 plus mg by 8. Is it clear? So this is the 8, 4 mg plus mg is equal to 5 mg by 8 is the tension in the string. You understand this question? Can you check the answer? Copy this.